So today we went over financial packet, and the first thing we covered is personal and family budgets. So first thing I'm going to do is I'm going to write in these two numbers for housing that is difficult to read on your paper, and taxes. So this is our tax, and 1540 is our housing. So the first thing it asks is to determine the total of all budgeted expenses. So the way you do that is you just add everything up. I just go around, make sure I don't forget anything. So I take all my different components of my budget and I add them all together, and my total is $5,500. Next step is number 2. What percent of the total budget is for college savings or for food? So I'm going to put college over here and food. So I go up to my graph and I find college savings, and they're saving $550 a month toward college. So I'm just going to divide 5,500 into 550. Clearly that doesn't go, so I'm going to put my decimal and add a 0. Now that goes evenly in one time. So 0.1 is what they are spending, part of their budget, but we want to convert that to decimals, convert that to percent rather. So we're going to move our decimal 2 places to the right. So 10% is what they're saving for college out of their budget. Now food, let's go find food. $440 a month for food. The process is the same. That doesn't go, so I'm going to add my decimal and another 0. It still doesn't go because 4,400 is less than 5,500. I'm going to add yet another 0. Let me see. 7 times 5 is 35. 8 times 5 is 40. I think it's going to be 8. 8 times 0 is 0, 8 times 0 is 0, 8 times 5 is 40, put my 0, carry my 4, 8 times 5 is 40, plus 4 is 44. So 0.08, which when we convert that to a percentage is 8%. So number 3 states if each parent worked 160 hours, so this was 2, and they earned a total, so a combined of $35 an hour for both of them together, would their income be less than, equal to, or greater than their budgeted expenses, and explain why. So we're going to take their 160 hours, we're going to multiply it by 35 and see what their total income is. So $5,600 is their total income, and that is greater than 55, which is their monthly expenses. So if they were making less than their monthly expenses were, they would need to find somewhere where they could reduce an expense so that their expenses would be less than their income, or they would have negative and they would go into debt each month. So what are the components of the budget? The components are just all these different things that we just added up. So it's all the expenses. And now we talked about fixed price, fixed expenses, and variable expenses. I just touched on that a little bit. Variable are things that you can change, and fixed are things that stay the same. So housing, taxes, your car note, those are things that you really can't change, unless, of course, you like sell your house or car and buy something else. But for the purpose of this budget, we're going to say we can't change those. So let's talk about variable expenses first, because the list is smaller. And our variable expenses in this list is food, clothing, and entertainment. So those are the areas that we could change, and or if we needed to reduce our budget, or if we were able to increase it. So all the other components are fixed. Okay, so we're going to skip the independent practice for later for you. Simple and compound interest. First of all, let's just talk briefly about what interest is in general. Interest can be positive and it can be negative. When you are the investor and you are investing money, so you're putting it into a financial institution, they will pay you interest, which is a small percentage of your principal, which is what your initial amount that you put in on for keeping your money in their banking institution, financial institution. Now, if there's also interest that, like if you take a car loan out, house loan, credit card debt, where you don't have that money, so you need to borrow the money, that interest you pay the financial institution. So those are the, kind of the different kinds of interest. And for this sake, we're an investor. We have money that we want to invest, and so we're going to see how much we can earn. So we initially put in $2,000. Our interest rate is 3%. We're going to leave it in this account for 4 years, and the interest is paid yearly. So we have $2,000. We have 3% interest. So don't forget our decimals. We have two numbers behind our decimal place, so we need to move our decimal 2 places over. So $60 is what we're going to earn on this $2,000 in 1 year. Well, we have 4 years, so we're just going to multiply that by 4 because our principal does not change here. So we earn $240 over 4 years interest. Now, compound interest, when you can get compound interest, that would be the way to go, because the way compound interest works is every time you it applies the interest, it adds it back to your principal. So your principal is steadily increasing, and meaning, so the next year you're getting interest not only on your original principal, but the interest that they put back in there. So the first year we already figured it out. We got $60 because our interest rate is the same. Our principal and interest are both the same as the problem before. $2,000 at 3%. So the first year we got 60. Now we're going to add that to our original 2,000. Now we have 2,060. So our second year we're going to earn interest on $2,060, or 3%. So the second year we earn $61.80. So I'm just writing off to the side here next to my table how much interest we're earning each year. We add that $61.80 back into our principal from the year before, and we have 2121.80. Again, we're going to get our 3% interest. So this time we have 1, 2, 3, 4 numbers behind our decimal. 1, 2, 3, 4. Our decimal goes here. Year 3, we earn 63.65. We add that back into our principal from the year before. Now our principal is $2,185.45. I'm just multiplying here. Okay, I have 4, again, 4 numbers behind. So I'm going to move my decimal over that many times to have 65, 56. Now I figured out how much interest I've earned each year, and I'm going to add them up. So I have 11, line up your decimals. So $251.01 interest, with the principal being the same, the interest rate being the same, but we're compounding annually instead of simple interest. So in the 4 years, you earn $11.01 more. Now, you can see the difference, but when this really starts making a big difference is when you get to like years 10, years 20, you're really going to see a huge difference between example 1 and example 2, and we're going to do an activity on Friday in class that will demonstrate that. So in these two scenarios, which interest plan earns the most interest? Compound interest. Okay. We're going to save the independent practice for later. We're going to monetary incentives. Monetary incentives is a financial reason to buy. So where a company will give you incentives to buy through sale, rebate, or coupon. A sale is just reduced amount on the price of the item. Rebate is a partial return or refund on the amount paid, so you pay for the product up front and then they give you the money back later. And a coupon is a voucher entitling the user to a cash refund at time of purchase. So determine the savings after a 15% rebate. We're comparing these two. We have a rebate and we have a sale price. So our 15% rebate on $28, remember to convert our percent to a decimal by moving our decimal place 2 places to the left. So we have 40. For 20, I need to move my 2 decimal places. So $4.20 would be your savings on the 15% rebate. Now look at the sales price over here. The original price was 28. The sale price is 24. We can do that in our head, mental math. So with the sale price is $4 off. So what is the best incentive to buy the pillow? It would be the rebate. You say save 20 more cents if you purchase through the rebate. Now, on down 4 through 6, we're going to use these two over here. We have a sale price up at the top, and then we have a coupon down here at the bottom. So the sale price says, Deidre wants to buy 2 large 1-topping pizzas. How much would she pay altogether if she used the Pizza Time sale price? So we're looking at the Pizza Time sale price. Normally, large pizza is $9.99, on sale for $8.99. We're just going to add 2 of those together because she's buying 2. So she spends $17.98 if she purchases from Pizza Time. That's their sale price. Now let's look at Pizza Parlor. They have buy one, get one free, and one pizza costs $16.99. So there she's going to get both pizzas for $16.99. So what would be the better deal? The coupon from Pizza Parlor. Okay, Friday we will probably do the independent practices. Hopefully we'll have time to finish it in class, and we'll have a hands-on activity to demonstrate simple and compound interest. Thank you.